Okay, so you sent us like a ton of research about this thing.
Yeah.
Human MetaPneumoVirus or HMPV.
Right.
And it seems like you're like really trying to stay ahead of this whole like respiratory thing that's emerging. And luckily for you, that's where we come in.
Yep.
So you've got like excerpts from a study on some natural compounds that could potentially treat HMPV.
Yes.
And then like a medical journal article about an older adult who got really sick with it. And then a preprint about the recent outbreak in East Asia.
Yeah.
And that one has some like pretty radical new approaches to vaccination.
It's a pretty fascinating collection, actually.
Yeah.
It really does highlight just how HIPV is only just starting to get the attention it deserves.
Yeah, I was really surprised to learn it was only discovered in 2001.
Really?
Seems kind of late in the game for us to be finding, like, new viruses.
Well, it's not exactly new.
Yeah.
It's just that we've only recently developed the tools to properly identify it.
Okay.
Molecular diagnostics have been like a total game changer. For a while, HMPV probably flew under the radar.
Ah.
Probably mistaken for other respiratory illnesses.
So, like, it's not just a harmless sniffle, then?
Definitely not.
Okay.
It causes a range of like respiratory issues from like mild colds to severe bronchitis and pneumonia.
Wow.
We always knew it was a risk for young children and the elderly and people with, weakened immune systems.
Yeah.
But what's concerning is that we're seeing more and more cases of healthy adults getting seriously ill from HMPV.
Yeah, like this 68-year-old runner in the case study you mentioned. He ended up in the hospital with severe pneumonia.
Right.
And it was all from HMPV.
This case, actually published in the journal Microorganisms,
Oh, wow.
is a real stark reminder that HMPV can impact anyone.
Oh, yeah.
And his case is pretty typical of how the infection can progress.
Okay.
It starts off looking like a common cold, so you get a sore throat and a cough. But then it can escalate pretty quickly to more severe symptoms like congestion, difficulty breathing, and even loss of smell and taste.
Oh, that's kind of worrying.
Yeah.
Especially since it sounds like so many other viruses.
Yeah.
Like COVID or even the flu.
Right.
How do doctors even know what they're dealing with?
That's the big challenge. And that's why this case study is so important.
Yeah.
The patient was initially given antibiotics
Oh, wow.
because they thought he had bacterial pneumonia. It wasn't until they did a multiplex RT-PCR test,
Okay.
a type of molecular diagnostic, that they realized it was HMPV.
So you're saying a lot of people are probably being misdiagnosed
It's certainly possible.
and given antibiotics they don't need.
And that's a problem for a couple of reasons.
Okay.
First, antibiotics won't treat a viral infection like HMPV.
Yeah.
And second, overusing antibiotics contributes to antibiotic resistance,
Right.
which is a huge threat to public health.
So this case is really emphasizing the need for better diagnostic tools.
Absolutely.
Yeah.
Wider adoption of these rapid molecular tests would be like a major step forward.
Yeah.
They can quickly and accurately pinpoint HMPV, which means patients get the right treatment
Okay.
and we avoid unnecessarily contributing to the problem of antibiotic resistance.
Okay. So that addresses like the diagnostic side of things.
Right.
But what about actual treatments for HMPV? Is there anything out there yet?
Right now, treatment is mostly supportive care. So like managing symptoms,
Okay.
making sure people stay hydrated,
Yeah.
and providing oxygen support if needed.
Okay.
But the good news is there is some promising research happening,
Okay.
exploring a few different options.
Okay.
One avenue that's particularly interesting is the use of natural compounds to fight the virus.
Yeah.
There's a study in the journal Biomolecules that highlights some exciting possibilities.
Oh, cool. Yeah, I saw that. It's the one about like green tea, right? Like, are we all going to be drinking green tea to like fight off HMPV?
Well, not exactly.
Okay.
It's a little more complex than that.
Okay.
The study focuses on a compound called epigallocatechin gallate, or EGCG for short, which is found in green tea. They also looked at rutin, which is found in citrus fruits,
Great.
and quercetin found in things like onions and apples and berries.
Okay, so how are they using these compounds to target the virus?
Right.
It's not like they're making like a green tea-infused inhaler or anything, are they?
Not quite.
Okay.
They use computer simulations and molecular docking studies
Okay.
to see how these compounds interact with the virus
Yeah.
at a molecular level.
Okay.
Specifically, they were looking at the HMPV matrix protein, which is crucial for the virus to replicate.
And what did they find?
So
Did these compounds actually stick to the virus?
they did.
Really?
And what's particularly exciting is that EGCG,
Yeah.
the compound from green tea,
Yeah?
showed a really strong binding affinity to the HMPV matrix protein.
Wow.
This suggests that it could potentially block the virus from replicating.
So does this mean we're like on the verge of having a green tea-based antiviral for HMPV?
It's too early to say for sure.
Yeah.
These are promising findings, but they're still preliminary.
Yeah.
We need more research, especially lab studies and clinical trials, to confirm whether these compounds are safe and effective in humans.
Right.
But it definitely opens up a new avenue for treatment development.
Yeah.
And what makes EGCG so interesting is that it's remarkably stable and has these positive electronic properties, which suggests it could be a potent inhibitor.
So green tea might actually hold the key to fighting this virus.
It's possible.
That's pretty amazing.
Yeah.
But what about the other articles you mentioned?
Yeah.
The ones about vaccines. Is there anything promising happening on that front?
Definitely.
Okay.
You sent over a preprint article,
Yeah.
which means it hasn't been peer reviewed yet,
Right.
but it presents some really intriguing ideas
Okay.
about shifting our approach to vaccination.
Yeah. The authors seem to be really pushing for a greater focus on what they call like natural immunity component, particularly these things called interferons. What exactly are those?
So interferons are proteins that our bodies produce naturally to fight off viruses. They're like our first line of defense, triggering a cascade of immune responses. The article suggests that we should be looking at incorporating low doses of interferons into vaccines. Or even using them as a treatment on their own.
So they'd be like little immune system boosters, helping our bodies fight off HMPV more effectively.
Exactly.
So,
It's a fascinating concept because it would be tapping into our body's own defenses and amplifying them. Instead of just relying on antibodies, which is what traditional vaccines do.
Right.
We could be like supercharging our natural ability to fight off viruses.
Okay, but how would that like work in practice? Would we be getting like interferon injections or something?
The article suggests a few different approaches.
Okay.
One idea is to incorporate low doses of interferons into existing vaccine platforms.
Okay.
Another is to use them as adjuvants.
Okay.
Which are substances that enhance the immune response to a vaccine.
Got it.
And there's even some discussion about using interferons as a standalone treatment.
Okay.
Similar to how we use antivirals.
That all sounds pretty promising.
Yeah.
Oh, the article also mentioned something about gene editing.
Right.
And using viruses themselves as vaccines.
Yes.
That sounds a little out there.
It does sound like science fiction.
Yeah.
But it's a concept that's gaining traction in vaccine development.
Okay.
The idea is to take a harmless virus, like a rhinovirus, which causes the common cold, and genetically modify it.
Okay.
You could either remove the genes that suppress the interferon response, making the virus more susceptible to our natural defenses, or you could even insert interferon encoding genes directly into the virus.
So you're basically reprogramming the virus.
Precisely.
To trigger a strong interferon response.
Instead of causing illness. The modified virus would actually stimulate the production of interferons.
Okay.
Boosting the immune system. And because the virus replicates, it would continuously amplify the interferon signal.
Okay.
Leading to a longer lasting immune response.
Yeah. That's pretty incredible.
It is.
And could this approach work for other viruses too?
Potentially.
Yes, not just HMPV.
But it's important to remember that this is still a very new and experimental area of research.
Okay.
We'll need a lot more research and rigorous safety testing before we see this kind of approach being used in humans.
It's definitely a lot to think about.
Yeah, it is.
So let's bring it back to the listener for a second.
Okay.
What are the key takeaways from all of this? Well, we've covered a lot of ground here.
We have.
It seems like HMPV is a much bigger deal than most people realize.
Yeah, I think you're right.
It's easily misdiagnosed. There's no specific treatment yet.
Not yet.
And it can hit even healthy adults hard.
That's right. Yeah.
So, yeah.
You mentioned earlier that right now treatment is mainly focused on managing symptoms.
Right.
But with all this exciting research happening,
Yeah.
Are you hopeful that we'll have like more effective treatments for HMPV in the near future?
I am optimistic.
Okay.
The research into natural compounds like EGCG is particularly promising because it suggests we might be able to harness the power of readily available substances to fight this virus.
Okay.
And the exploration of new immunological approaches, like incorporating interferons into vaccines or even using them as standalone treatments, is potentially groundbreaking.
It's fascinating to think we might one day be able to reprogram viruses to help us fight off other viruses.
Yeah.
It's like turning our enemies against themselves.
It's a very elegant approach.
Yeah.
And it speaks to the incredible ingenuity of the human mind when it comes to tackling complex challenges. But it's also a reminder that we're in a constant race against these viruses.
Right.
They're constantly evolving.
Yeah. And we need to keep innovating and adapting our strategies to stay ahead of the game.
It all sounds like the future of HMPV research is full of possibilities, but also challenges.
Exactly.
Yeah.
There's still a lot we don't know about this virus, and there are many hurdles to overcome in developing effective treatments and vaccines.
Right.
But the research we've discussed today gives me hope that we're on the right track.
Okay.
And the more we learn about HMPV, the more we'll understand about viruses in general.
Okay.
Which will ultimately help us fight off a whole range of emerging threats.
Well, I think you've given our listener a lot to consider.
I hope so.
HMPV is definitely something to keep an eye on.
Yeah.
But it's also clear that there's a lot of brilliant work being done to understand and combat this emerging threat.
Absolutely.
Any final thoughts before we wrap up our deep dive?
I just encourage everyone to stay curious and informed.
Yeah.
The world of virology is constantly evolving, and there's always something new to learn.
Yeah.
And remember, knowledge is power. The more we understand about these viruses, the better prepared we'll be to protect ourselves and our communities.
Great advice. Thanks for joining us on this deep dive into the world of HMPV.
Yeah, thanks for having me.
We hope you found it informative and maybe even a little bit inspiring.
Yeah.
Until next time, keep exploring and keep learning.